All right, this is lesson 113. So remember, you're going to do the odds on this lesson. And it's talking about the volume of pyramids, cones, and spheres. So to find the volume of a pyramid or of a cone, you're going to take 1/3 and multiply it times the area of the base times the height. So that capital B stands for the area of the base, not just a side of the base. So whatever the shape of the base is, we'll find the area of it, multiply times the height, and if it tells us it's a pyramid or a cone, then we'll divide it by 3, which is the same as multiplying by 1/3. So you do need to memorize this formula right here, okay? All right, it says, the pyramid at right has the same base and height as the cube that contains it. Remember, a cube has all equal sides, so the length of the side is 6. So the base of that pyramid is a square, isn't it? It's 6 times 6. So as far as the area of the base goes, we know that the area is 6 times 6, which is 36. So we put that right here for B. I'm going to put the 1/3 in front. And it's a cube. So what's the height of the cube? It's the same as the other sides, isn't it? So the height is also 6. So the volume of that pyramid that is stuck inside of that cube comes out to be 1/3 times the area of the base is 36 times 6. So I can just cross cancel. This 3 goes into the 6 twice, doesn't it? So the volume is 2 times 36, which is 72. And it said those were centimeters, so that would be centimeters cubed. All right, next. On page 791, the volume of the cone, it works exactly the same way. The difference is a cone has a circle for a base, so the area of that base is going to be pi r squared. So the volume of the cone becomes 1/3 times pi r squared times h. So you don't have to memorize that so much. If you can remember that the area of the circle is pi r squared, then you can always refer to this other formula for the area of the base. It'll work out the same way. So this one says find the volume of this circular cone. It has a radius of, what is the radius? If the diameter is 20, what's the radius? Okay, the radius is half of that, isn't it? So the radius is 10. So we're going to put in here 1/3 pi, and it tells us to use 3.14. And the radius is 10, so it's 10 squared. And now how tall is this cone? Looks like the height is 30, isn't it? Sorry, I ran out of room. Okay, so, well, the nice thing about that is this 3 will cancel into the 30 and give us a 10. So we have 10 squared, which is 100, isn't it? And then 100 times 10 is 1,000. So we have 3.14 times 1,000. Okay, and when you multiply by 1,000, that's how many zeros? It's 3. 3 zeros in 1,000. So you move the decimal over 3 places. So the volume is going to be 1233140. And the units on that were, does it say? Centimeters. So this is centimeters cubed also. All right, so the the pyramid and the cone are the same. You work them out the same. Now, if you look at page 792, they show you something that's really interesting about the cone and a sphere. There's a different formula for the sphere, and you can see that. If you look at that picture at the top of page 792, which one of those figures, the cone or the sphere, is taking up more of that cylinder? It looks like there's more open space around that cone than the sphere, doesn't it? Well, it turns out that that is the case. If you were to find the volume of that cylinder, to find the volume of the sphere, you'd multiply it by 2/3. But we're not going to do it that way. So what I'm saying is the volume of the cone is 1/3 the volume of the cylinder, right? The volume of a sphere is actually 2/3 the volume of the cylinder. But you don't need to remember this. I'm just giving you that information so that you can see that's why they drew that diagram in there. So the formula for the volume of a sphere that we're going to use is this: 4/3 pi r cubed. And you don't need to get it confused with the area formula, because area has 2 dimensions, volume has 3. So that's why we have the r cubed, is that r cubed gives us the 3rd dimension. If it was r squared, it would just be area. Okay, so there's only one variable here, and it's the radius. So if it asks us to find the volume of that sphere, we'd simply plug in whatever the radius is. So look at the bottom of page 793. It says a ball with a diameter of 20 centimeters has a volume of how many cubic centimeters? Well, they give us the diameter instead of the radius. So the diameter is 20. So what's the radius? It's half that, okay? It's 10 centimeters. All right, so we're just going to put it in. It's 4/3 pi times 10 cubed. So the volume's going to be 4/3. And let's see, what does it say to use? Round the answer to the nearest 100. Okay, so we're going to use 3.14 for pi. And then 10 cubed is 1 with 3 zeros, isn't it? All right, so if I multiply 1,000 times 3.14, that's going to give me 3,140. And then we have to multiply that times the 4/3. Okay, let's see. 3 doesn't go in there evenly, so this would be 0, 16, 5, 12 over 3. And it wants us to round it off to the nearest 100, so let's just divide this out. See, that's 4. 1, 26 would be 8, 20 would be 6, and then it would be, there'd be 2 left over. So it wants us to round it to the nearest 100. So if you're rounding to the nearest 100, that 8 is going to change the 1 to a what? Okay, it's going to change it to a 2. So rounding it would be 4,200 cubic centimeters. All right, so remember on that lesson, you're doing the odds, and on 112, you're doing the evens. And so if you'll just email this message to me, the email address is this. Okay, I'll see you guys tomorrow. Thank you.